Thank you. And thank you for the invitation to come and speak to you. So I'd like to talk to you today about work that actually some of my students do. I mean, I don't know that I actually do any work. Okay. I saw a review in Nature last week of E.O. Wilson's latest book, Half Earth. And apparently the premise of this book is that we should set aside half of the Earth for the rest of the biota. I haven't actually seen the book yet. And you could ask, why half? Why not 3/4? Why not 1/4? How much is reasonable? So basically that's the question I'll be talking about today. And I'll start off with a bunch of stuff that's probably obvious to everyone here, but maybe we'll just get us going. So first obvious thing, human activities remove natural cover. Probably mostly for agricultural reasons, but beyond agricultural reasons, there's also human settlement that takes natural cover, and up in the upper right, resource extraction. Okay, second obvious thing, my daughter had a t-shirt that said, if you cut down all the trees, the birdies will have no place to sit. And I now regret not having a picture of her with it. But anyway, so habitat loss is, according to the accepted wisdom, bad. And certainly at the limit, this is true. This is the tar sands in Alberta, Canada's most famous industrial project, and I think the birdies have no place to sit in that particular case. Okay, in a more citable form, I would like to point to an article from this research group, that for landscapes undergoing habitat loss and fragmentation, the effect of losing habitat is obvious. When habitat is lost, dependent species are also likely to be lost and populations decline. So I think that's a reasonable summary of the accepted wisdom in this field. Okay, so like the conservation question that interests me, I'm a much less practical conservation biologist than the people on the 5th floor of Goddard are. So you'll have to bear with me because I'm more of a macroecologist than a bona fide conservation person. So how extensive will species losses be as a function of habitat loss? Or perhaps in different words, if people and the rest of the biota are going to share the planet, how much can we take reasonably? The theoretical basis that's been used to address this question in the past, and you've all heard this before, is the species area relationship from MacArthur and Wilson's island biogeography, according to which the number of species on an island, in this case in the Caribbean, increases as a function of the area of the island, and this works for any group of organisms you care to look at. The bigger the area, the more species there are. And in this context, land is regarded as habitable and the water surrounding the land is regarded as not habitable. Okay, I need to talk about this relationship in linear space rather than logarithmic. So MacArthur and Wilson's graph is on log-log scales. If you back transform this, the number of species increases as an exponential function of land area in this relationship. And it gives you a curve that's shaped roughly like that, which I just drew by hand. Okay, so this has often been applied in conservation, and the notion is that, again, drawing from MacArthur and Wilson's book, in 1831 in Wisconsin there was more or less continuous forest, and by the middle of the 20th century there were little patches of it scattered around in wherever that is in Wisconsin. And the notion was that you could use the relationship between patch, habitat, patch area, and number of species to say how many species would be found in that little patch of forest that an arrow is indicating. And the rest of the stuff around it is matrix, which has been treated in various ways in the literature, but let's say to a first approximation, matrix is not habitable. And I know that there are studies that have dealt with that. So the first problem is that when you do this, these species area relationships overestimate species loss from habitat loss. So Him and Askins had a paper in '95 in PNAS where they pointed out that there's been extensive forest loss in eastern North America, that there are around 200 species of forest birds in eastern North America, and only 4 of them have gone extinct. They ultimately said that this was consistent with the theory by diddling exactly how you define how many species are eligible to go extinct, and I might get back to that later. A more recent paper by he and Hubble in Nature says species-area relationships always overestimate extinction rates from habitat loss. Okay, and their idea was fairly simple, that if you start off with some area of habitat, you can, from this relationship, figure out how many species there will be. And if, over time, some chunk of this habitat gets converted, you can then take the area of the remaining amount of habitat and calculate how many species would be. And that would be the prediction just straight from the species-area relationship. But he and Hubble pointed out that what is really important is not so much how many species would inhabit the area that's remaining, but how many species would be found uniquely in that part that was cleared. So the endemic species to the lost part of the habitat. And if you do that, you can generate a curve, the red curve that I put on this graph. So the blue one is the same one that I showed you a moment ago. So the red curve is the endemic richness relationship, which is just the number of species lost as a function of area. And basically the notion is if the area is small over here, there will be very few species that are restricted to that area. So losing that area will not cause the species to be lost. And then it increases rapidly on the right side of the graph. Okay, so this was he and Hubble's solution to the problem. And they approached this by, well, not a macroecological method. They did this on a theoretical level. But there are a bunch of problems. The first problem is that species-area relationships and endemic area relationships are based on richness in habitat patches. So you could take the area of that patch or the area of that patch and calculate how many species you would expect to find in them, or how many species would be left if you destroyed everything else. But in practice, I don't know when one would actually ever want to predict the richness in a patch. I mean, much more usually, people would be concerned about the numbers of species and which species, which I'll get to in a moment, in some sort of administrative unit, like a park, a reserve, a municipality. You might want to have a plan for the city of Brisbane for protecting diversity. And whether something is in New Farm Park or not probably doesn't matter if it's somewhere else in the region. So, first problem is that this more commonly applied approach has been applied to patches, and so has virtually all of the experimental work in this field has focused on patches as opposed to landscapes. And the second problem is that it assumes, when you started with the McArthur-Wilson sort of model, it assumes that the matrix is lost, is gone, and that what is happening on continents is you start with forest, which is habitat, and convert it to something else that is not habitat. Whereas it's clear that there are other things that are going on, that habitat is not lost, it's converted to something else. And my house in Ottawa sits right there where the red arrow is, just on the edge of an agricultural field and deepest, darkest suburbia. And in my garden, there are all kinds of interesting things that seem to regard it as habitat. So I would say that this stuff is not lost. It's certainly not forested habitat in my garden, but it's not lost. Okay, so here's the question we started with for the research purposes. If you've got landscapes that are partly converted to human-dominated covers, first of all, how much would you expect species richness to decline? And how much does the probability of occurrence of individual species in that landscape decline? Because we might not be uniquely or solely interested in how many species. We might want to know which ones are going to do badly or do well. So some of my students and I addressed this question in southern Ontario, Canada, which is the area in the square. Southern Ontario was historically virtually entirely forested. It was settled primarily in the 18th and 19th centuries, settled for agriculture and partly deforested. And now there's a mix of land cover types. In the southwestern part of the province, it's quite intensive industrial agriculture. In the middle there is Toronto. There's a big urban area. There's a forested, almost entirely forested area between Toronto and Ottawa. And up where I've said market farming is near Ottawa. It's mostly small agriculture. So there's quite a mix of habitat types here. So what we did was look at birds. Not that I know much about birds in particular, but there are a lot of data on birds, so that's why I study birds. And I'm perfectly happy to study anything else for which there are data. We used the Atlas of Breeding Birds of Ontario, in which an army of volunteers went out and scoured quadrats between 2000 and 2005. These quadrats are 10 kilometers by 10 kilometers and cover that southern bit of the province. There are 991 of these quadrats, which we regarded as landscapes. 991 landscapes that had been, to greater or lesser degrees, deforested over the last couple of centuries. I should also add that deforested primarily in the 18th and 19th centuries. That's when the area was settled. The land that was arable was cleared, and the rest is pretty much left as it is. So not too much has happened in southern Ontario since that time. So what I'm looking at now is what I would consider to be a natural experiment that took place a century ago, or a century and a half ago, in which the cover was removed in these 991 landscapes that are each 100 square kilometers. Okay, so the first thing we did was look at the species richness, or you can take these maps of presence-absence of birds and just overlay them all and tally up how many species there are in any given quadrat. And what you'd expect to find from the species area relationship is more or less the blue curve. The endemic area relationship has about the same shape, but it's shifted a bit. So that's what you'd expect to find. This is what we did find. So we found a peaked relationship between the number of species in a 100-kilometer landscape and the proportion of natural area as assessed by remote sensing. So natural area, in the case of Ontario, is forested. There's also some wetland in the natural area, but it's, to a first approximation, it's forested. And to a first approximation, there's no grassland sorts of habitats in southern Ontario. So we didn't get exponential relationships. We got this peaked relationship, which is really kind of interesting, and led to the notion that you can remove half of the forest and it's actually better for the birds. Okay, so why would we get this? So the first thing we proposed was that, well, in fact, so MacArthur and Wilson treated birds as one group. And I'm always interested in the simplest model that I can propose to account for the data. So suppose we say that there are two guilds of birds and two types of habitats. There's first of all forest and forest interior birds. And if we have percent natural area here going from no forest to 100% forest, we could get a species area curve along the dashed line that would represent how many species of forest birds are there. This gradient in the opposite direction goes from 0% human-dominated habitat to 100%. And so you might have, we postulated that there's a second group of birds that prefer open habitats. And human-dominated covers are typically open. And this is a second species area curve that runs in the other direction. And if you add the two of them, then you get the curve on the top that has a peak in the middle. Okay, so this was the hypothesis. So when we looked at, so the first predictions of this are that we should get these two species area sorts of relationships with the two guilds. Here are the forest birds. So this is on the y-axis is the number of species of forest birds, on the x-axis the proportion of forest cover. I overlaid in blue what the species area relationship would be, and the rest of the curves we don't really need for right now. But The short answer is it works. For forest birds, you get exactly what you'd expect from a species area relationship, not the endemic area relationship, actually. The species area one worked better than he and Hubble's model did, which is kind of interesting. For the open habitat birds, again, when I tried to overlay in blue the species area relationship, the open habitat birds didn't behave as expected. They showed a peaked relationship along this gradient of human-dominated cover, which in this case is simply 1 minus forest cover. So this is entirely forested, this is no forest at all. You have a peaked relationship. That's interesting. So our first model is wrong. So what we proposed was a modification of this model with essentially 3 land cover types. Forest, open habitat that birds can use, and open habitat or human-dominated habitat that they can't use. So an actual lost chunk. And we didn't, I'll be upfront about this, we didn't have a good way to estimate what lost habitat is except as assessed by the birds. So this is proposing that the proportion of lost habitat increases exponentially as a function of how much is human-dominated. And we fit this to the patterns of richness. And what we got out of this, first of all, was a model that accounts for that peaked relationship between open habitat and open habitat bird richness that works well. And we find that there's a chunk in here of area that is available, of human-dominated habitat that is available, like my backyard. And there's also a chunk that is lost. And what appears to be happening is that when in a landscape, when there's relatively little human-dominated cover, it's primarily available. As the human domination of the landscape becomes more and more intensive, the proportion of that that's available for birds decreases. But interestingly, the greatest amount of this habitat is here at about 61% human-dominated. So only a third of the habitat is not lost in the MacArthur-Wilson sense. Okay, so when you talk to people who know more about birds than I do about this, the first thing that they will say, of course, is, oh, well, what you're doing is trading valuable forest interior species for human-commensal species like crows and starlings and house finches and the European house sparrow and horrible things like that. Okay. So to address this, what we did was look at each individual species, and we fit a logistic model of probability of occurrence as a function of either how much forest was there or how much human-dominated cover is there to get positive relationships in all cases. So in this graph, on the right, these are species that increased in abundance if we simply postulate going from 100% forest to 50% forest. These are species that would do better, increase their probability of occurrence, with half of the forest being removed. These are species that would do worse. There are more species that do better when you take away some of the forest than there are when you leave the forest. And this makes sense because of that peaked relationship. There have to be more that like in the middle. The bars here represent decrease in probability of occurrence of 0 to 10%, 10 to 20, 20 to 30, and so on. So these are the species whose probability of occurrence decreases by more than 50%. And it's only 12% of the species whose probability of occurrence goes down by more than 50%. Fully a third of the species are twice as likely to be present in a landscape that's half forest, half open. And when you look at which ones, it's really kind of interesting. So the species that do well are to a degree those human-commensal species. But there are a whole bunch of species that are associated with early successional habitats. And early successional habitats, at least in the context of southern Ontario, are actually kind of rare. That either forest has been allowed to develop into forest, or it's been paved. And there's not really much intermediate between the two. And so the species that did better are partly human-commensals, but there are several species in that group that are actually red-listed in Ontario. So removing half the forest is good for these guys. The losers. There are a bunch of species. So if I took the species, the 12 that were way out there that were most negatively affected, they included this duck and the bay-breasted warbler and the woodpecker. There were no species at risk among the species that were most negatively affected. And the really interesting thing is, if you look at their distributions, all of them, without exception, all of them are species whose range is mostly up north, are mostly boreal, and they're at the southern edge of their range. Those are the ones that were really negatively affected by the fragmented landscapes, or the reduced landscapes. So I thought that was really interesting, because they're species that are common if you go 200 kilometers north, but are not when their range comes into the southern margin of their range came into our study area. Okay, I was asked to speak for only 20 minutes, so I decided not to go further. Other results that are kind of interesting. We also asked, is there an effect of fragmentation beyond simply the total quantity of habitat? Lenore Farrig had a paper in Journal of Biogeography last year or 2 years ago or something like this, where she said fragmentation doesn't matter beyond how much total habitat there is, that total habitat captures whatever fragmentation signal there is. So we tested that, and the results we found were consistent with Farrig, that for species richness, any measure of fragmentation that you put in accounts for nothing. And you can look at each individual species, and there are 3 or 4 where it goes in, but when you've got 200, you would expect there to be 3 or 4 where it works. The other really interesting thing is that species at their northern range margins virtually all benefited from this hypothetical reduction of forest from 100% cover to 50% cover. So the literature, the climate change literature is concerned that if climate warms and species try to move north, that they will be impeded from doing so because of habitat fragmentation. Well, what we found is all of those species that are at the northern range margins are actually do better have a higher probability of occurrence in these landscapes that are partly forested and partly open. And I wonder if perhaps it is because those landscapes might be easier to invade, in fact, than closed forest. So is fragmentation going to prevent species from moving forward if it warms? Well, our results seem to say exactly the opposite. So, to conclude, I'll go back to the Mantika Pringle quote. For landscapes undergoing habitat loss, so at least for birds in southern Ontario, we haven't done anything else, habitat is not lost, it's converted to other things. And when it's converted to other things, some of it apparently is simply lost. But some of it is actually new habitat for species that are desirable. Fragmentation. After accounting for total habitat area, fragmentation measures do not improve prediction of richness or species probability of occurrence. Which is kind of interesting because models like Marxan include a term in there that takes into account this. So for at least for the birds, it doesn't seem to tell you anything beyond total area. And I hasten to add, this doesn't mean that fragmentation is unimportant. It means that area, whatever happens as area is lost, it captures the signal well enough without having to worry about anything more. Species will also be lost. Well, at the limit, undoubtedly so. But if at least at 50% habitat conversion, are only 1 or 2 species that really went down a lot. Very few. And there are a whole whack that benefited considerably. So, is half actually reasonable? Probably. So I'll leave it there. Rafael de Camargo did most of the research, and it got paid for by the Federal Granting Council in Canada. I'm happy to entertain questions.
I wonder with the dimensions that you use for landscapes and things, was there also a temporal component to that, and how much that changes over time, and what effect time may or may not have on those curves?
So among the other things that we've done, this atlas was also done in the 1980s. So in a separate study, we also looked at the changes in occupancy between 1980s and the present. And one of the things we looked at was the question, can you predict which quadrats will have extinctions between the 20 years and which will have colonizations? And what came out of all of this was we couldn't find any measure of habitat suitability that predicted those changes, but the proportion of quadrats in the neighborhood that were occupied in 1980 was a very good predictor of, in 2000, whether colonization would have occurred. So there appears to be, I think what's happening is that the suitability of the habitat is much less important than colonization extent events that are more or less stochastic. We've done other things with the temporal as well, and there hasn't. So we've also looked at change in cover. So this is over those 20 years, and the problem turned out to be that there was so little change in cover that it didn't provide a convincing test of whether these temporal patterns can be, or whether the spatial patterns can be extrapolated through time. There just hasn't been enough change in cover.
I'm just curious, do you think you would get a similar or different result if you repeated this in perhaps the tropics with more range of species?
I'd love to know, and Rafael is Brazilian, and one of the things that we want to do is to do this in Brazil. But you need a large number of replicate landscapes to make this work. And so far we haven't found a good set of data. So the answer is, I don't know. But I'd really love to know.
Something on the time scale, which is kind of probably would be possible to look at, but more interesting with what went extinct very or moved on very early on when the period actually happened. As you say, the landscape tends to be relatively stable. So I wonder if there are things like, I don't know, there are records of people kind of exploring. There's a lot of bird watching and things like that in the early days. But obviously, that's the big change time, although they both existed for a few decades, they were on that existed for 150 years if they were particularly sensitive.
That would certainly be interesting to look at. I don't think 150 years ago that there were many people watching birds in that part of the world. They were trying not to freeze.
Just about the scale of the measurement of the response, basically. I was wondering, because obviously, whether you say half the habitat is lost within this 10-kilometer land parcels.
10 by 10.
Yeah, and if you made this larger or smaller, that would probably across the whole region in a quite agricultural area, probably that would change this relationship or the amount of habitat lost. So basically, my question is: would you expect that the curve looks different if you changed your scale of measurement?
Again, that's a good question. I don't know. It would be easy to...
Or how did you come to that scale?
Well, we came to that scale because that was the scale on which the bird censusings were done. So we just stuck with it. It would be easy to scale up to add them together, which I think would be a useful exercise. We haven't done it yet. I don't know how you go in the other direction. But quite conceivably, there may be scale effects here.
I haven't thought it through, but maybe some of the types of birds are affected by the habitat at different scales.
It must be scale dependent because at the limit, if you're looking at one tree, things kind of come and go. Somewhere in there will be scale dependence for sure. The rationale that we give for these 100 square kilometer chunks is that if you look at the distributions of reserve sizes, that's close to a median reserve size. And if you look at the distribution of sizes of municipalities, that's close to a municipality. So it's close to the sort of area that people might be expected to manage. But I completely agree that this may be scale dependent and we haven't yet. It's one of the things that I'm trying to push Raphael to do before you.
So you were talking right at the beginning about forest and matrix, and here you looked at forest. Have you looked at the matrix, using what that matrix is? For example, just using percent impermeable layers or lit areas, something like that?
No. So we could look at the matrix and see if we could improve the predictions. I think this would be a poor system in which to do that for the simple reason that the matrix, to a first approximation, is agricultural. I mean, if you look at what it actually is, it's over 90-some% of that area is agricultural. And there's very little resource extraction in this part of the province. And when you look for urban, cities are surprisingly small chunks of the landscape. So statistically, it would be hard with this method to pull out a signal, and we'd probably have to go at it some other way if we really wanted to look at the matrix. Because we just wouldn't have the statistical power to do it.
In a way you did, though. You said lost and created but not lost. You kind of divided the matrix.
Yes.
A couple of different categories.
And so one of the things that we did try to do was say, could we figure out, could we predict the amount that is open available and the amount that is lost from remote sensing images? And the answer turned out to be no. Unfortunately. We haven't found a way to say what is lost by remote sensing.
She had a good one, though. Percent impermeable might be a really close, I don't know how good it would be. Concrete or rooftops or whatever.
Yeah, but again, there's so little of southern Ontario that is impermeable. I mean, it's agri.
Lights is the other option.
I'm sorry?
Nighttime lights is the other option.
That would be interesting. Yeah. I suspect, and that wouldn't be hard to do. That's an interesting suggestion. I suspect that what we find is the same problem as with the impermeable. The lights are all around Toronto and Ottawa, and the rest of it's just a big void.
The other issue might be that actually cities have got a lot of potential resources for birds. They've got all these different parts and resources and things. So although we see them as quite unfriendly, I think they can have complex resources.
They do, and within the city of Toronto, as they are quick to point out, there are some considerable green areas. There are rivers, a number of rivers that go through the city and end up in Lake Ontario. And these gorges have been preserved as forest areas. And they are really quite nice. So within 100 square kilometers, the probability of catching some of those is high. If you really wanted to see impermeable, we probably have to get smaller squares somehow.
A place like Brisbane, it's on hand would be a great place to do this exact thing because the forest has that big grassland component that you're introducing with agriculture in Canada, so you're kind of adding extra species. But if you went to a place where there's already a lot of grassland, and we also have this strange degree of fragmentation here in Brisbane, where it's not a solid city, gone. It's a really, it's diffuse. And you might be able to quantify more fixed loss. And then what's shifted from forest, grassland, some substitute.
I think this is interesting enough that I would be really interested to do it again someplace else.
Oh, it's great. That's dangerous.
So you know, if there are data like this available from this part of the world, I'm in. You know, let me know. I'd love to.
You said that habitat fragmentation had no effect.
Right.
Given that it's a really agricultural area, does your region have a lot of linear connecting elements so the region isn't truly fragmented?
Well, you know, it does. These fields, let me pull up. Yeah, these fields very often do have hedgerows
Yeah.
that go between them. And you know, when I look out across my garden and across the fields, obviously in the field itself I don't see much. I see foxes running along the hedgerow all the time. And so yes, it is. There's a fair amount of connection in these landscapes. But some of the landscapes go way down to 10% cover. So, and those are areas in which it's industrial farming of tobacco and tomatoes in particular. And so now as far as the eye can see, it's tomatoes.
What was your measure of fragmentation?
We tried a bunch. And finally, the one that turned out to be the least collinear with total habitat amount was number of habitat patches, number of fragments. So that's what we ended up using in these models. But we tried a half a dozen other ones, and to a first approximation, they all get the same answer.
Because as you mentioned, and it may or may not be obvious, it's just that usually this fragmentation is you have to pick a cover type to base your fragmentation on. And as you said, the matrix isn't really lost. It's not really fragmented on a species richness envelope. Fragmentation only becomes important to a single species.
Oh, so we put fragmentation in those single species models as well. And it comes out out of the 200 species, it comes out in a dozen or something like that.
Maybe wild turkeys.
So,
it'll only be a slight.
and so the multiple comparison problem immediately pops up, and we got about as many species as you'd expect to get by chance.
So, brings an extent of the fundamental problem of all every landscape.
Yeah.
Just pull this hair out of it. This is great. I love it.
Thank you.
Have you ever mapping the endangered species or threatened species onto that big graph that you had of forest cover and dead species? I mean, where do they all fall?
Where do they fall? You know, the trouble with endangered species in Canada. Where's I need Canada here. Okay. The trouble with looking at endangered species in Canada is that it is viewed from a uniquely Canadian perspective, not a North American perspective. And so you often find endangered species right there on that little peninsula that is the southernmost point in Canada. And you go further into the US and they're all over the place, but it happens that the one population is there. And I've just despaired of all of that. It only makes sense to look at it in a North American context, not in a Canadian context, and that's not what they do.
Well, maybe just the species that are threatened across the whole range, not just Canadian.
So we haven't tried pulling out the ones that are threatened for reasons other than their range barely makes it into Canada. But I suspect that many of them are species whose ranges are barely getting into Canada. By and large, in the boreal forest further north, almost all species have really big ranges. And they're unlikely to be endangered.
I hope I didn't miss this early on, but you're using occupancy
Yes.
as a measure.
Yes.
Is there an equivalent breeding bird atlas or something in Canada that you might not get as large a data set, but you might get an idea of actually the value in the landscape on another scale for successful breeding? You know, they might forage across the landscape, but they're actually only using one component that's critical for their persistence or something like that.
So what we've got is, or what we've used are the data on, let me see, breeding evidence, which they have categorized into confirmed, probable, and possible.
Right.
We use probable and confirmed and left out anything else. So it's breeding evidence that all of this is based upon, not just being seen in the landscape.
Yeah, I was at an agroecology conference last year, and there people talk about edge effect, and that edge effect increases diversity, and they try and maximise edge in their designs in order to increase diversity. And I was like, and they were quite often when they were talking, they quite often slip in, oh, you get more biodiversity that way. I'm like, no, you don't. No, you don't. You can't just go from diversity locally to assume that that's going to increase life. But you can convince them. You go to the interior of the forest, there's nothing there. It's dark. There's hardly. Go to the edge, and there's all this life and abundance there. What you want to do is maximize that. And I thought that, hang on a minute, these guys need to talk to each other and work out. But I thought it was like what you said, that this is the weeds and the common species that you're just creating lots of, and you're losing the rarer stuff that can live in the interior. But yeah, there's a lot of people that think it works the other way around.
I think it's probably true, well, I'm certain that it's true actually, that on a very fine spatial scale, those edges do have more species than either way. But at the landscape scale, would you have more species because of a high concentration of? I doubt it. Yeah.
Do they come from a specific region, the things that they find, or?
Well, one of the people was particularly, I think they were talking about American or European forests, or largely pine forests. But they're talking about design at property scale.
Yeah. So at a very fine grain, it's probably true.
I'd be very careful to dismiss all of those people as lacking, because you come up against a lot of resistance when you put this research out. This can't possibly be.
Have you published it?
Yes. So, or part of this has been published.
Because some people are in the world, this is, that really makes a lot of sense. People who grassland areas and the like. As I see it.
don't make sense anyway, because diversity is probably, that's why ages is seen as important, as something else, you know. So I think in some ways it's very logical results. It's just nice to have actually found them, because one gets used to the species area curve, quite simplistic approach, so that actually quite complicated things actually.
So what I saw is nice about this was the macroecological approach to it, of having a large number of landscapes that could be compared, since that's relatively unusual. But that's my particular prejudice. I don't know if other people see that as a good thing or not.
When you're getting broad patches, almost sort of sampling effect for size.
That gets into a technical question, and I'd have to ask Raphael exactly how he counted.
It might be bird watchers only looking at certain types.
So the atlasing was done by assigning, or there were teams that were assigned to each one of those quadrats, and over 5 years they were supposed to go back and scour it to find all of the species that they could. Sampling effort varied among quadrats, and so sampling effort was included in these models actually, and it accounts for a significant fraction of the variance in species richness or in probability of presence. But in principle, they were supposed to scour the landscape and find everything they could and go back over 5 years to do this. How well?
I just had one last quick question. I think this is amazing to answer, but birds are obviously highly mobile. So this is very good news if you're a tweeter, whatever they call themselves. What if you're a moose or something far less mobile and you can't hop over fences?
Okay. One of the next things we want to do is there is an atlas of herpetiles being developed. The herps, I think that the answer to this question might be different when we get to the herps.
Yeah, and then we gain from mountains and we gain color.
So, I mean, it's a great question.
This is fantastic. I'd love to see this for some of these other things.
Yeah, and as soon as they keep saying, yes, it's coming, it's coming, it's coming. So as soon as I can get my hands on the data, that's coming.
Last positive message.